Very good morning to all my beloved students. Today, my topic is on recursion part. Now, recursion means process of solving a problem by reducing it to smaller versions of itself. More precisely, recursion is a technique that allows us to break down a problem into one or more sub-problems that are similar in form of original problem. So it is a method for solving those problems which fall into the divide and conquer paradigm. Now let us take an example. Suppose P is a procedure containing either a call statement to itself or a call statement to a second procedure that may eventually result in a call statement back to the original procedure P. Then P here is called a recursive procedure. Just like that, if inside the main function of considering a C program, if we write down inside main open brace, then have printf hello world, then again we write down the main part and close brace. Then the main function calls itself. So it is a one example of recursive function, right? So that the program will not continue to run indefinitely. A recursive procedure must have the following two properties, right? Here, as in the previous example, the procedure P is a recursive procedure. So here the following two properties are. Number one is there must be certain criteria called base criteria for which the procedure does not call itself. And the second one is that each time the procedure does call itself, that is directly or indirectly, it must be closer to the base criteria, right? Now I go to the second slide here where I also discuss about the direct versus indirect recursion, right? Now, before starting this, a recursive procedure with these two properties is said to be well defined. Okay. Now, here in this case, there are two types of recursion part. Here we consider recursion versus iteration part. This is the first part, belongs to recursion part, and the second one is direct versus indirect recursion. Okay. Now, here the recursive programs, though, are small and easy to write, but are not efficient in terms of the time and space complexity. So recursion may be implemented by means of stack. Already this part already we covered in our earlier slides, right? Now here in this case, that is iterative program, already all we know. Now here in the today's topic also we compare recursion versus iteration. And before starting this, at first we discuss the types of recursion. Now recursion is of two types depending on whether a function calls itself from it or whether two functions call one another mutually. Now the former is called direct recursion and latter is called the indirect recursion. Thus two types of recursion are, that is the number one is the direct recursion and second one is indirect recursion. And here both types of recursions basically can be shown with some example. That is, if we consider in the example that if the function name 1, okay, inside it after some lines, then again if we call the function name 1, then this is the example of direct recursion. Whereas in indirect recursion, if one function one part, here we define some quotes, then after that we call the function 2 part, and after some steps we close the definition block of function 1. Then after closing of the definition block of function 1, then we have to define the function 2. And here inside the function 2, after some lines, if again it calls a function 1, and then after some lines we have to close the definition block of function 2. So this type of example here is an example of indirect recursion, right? Now depending on the number of recursive calls, recursion can be further categorized as linear recursion, binary recursion, and multiple recursion. That is, these three types of recursion part also classified. Again, I repeat, depending on the number of recursive calls, recursion can be further categorized as linear recursion, number one, number two is binary recursion, and number three is multiple recursion, right? Now, in linear recursion, this can be defined as it performs a single recursive call. And if there are more than one recursive calls in a procedure, then only one of them should be chosen based on some tests or criteria. And the second one is that define each recursive call so that it makes progress to base case, right? Whereas in the second one, that is binary recursion, here this can be defined as it performs two recursive calls for each non-base case and define each recursive call so that it makes progress to base case, right? And here two recursive calls, so that's why it is called binary recursion. And the last one is the multiple recursion. Now, multiple recursion can be defined as it performs many recursive calls, that is more than two. If two, then binary recursion, and if more than two, then multiple recursion. So it performs many recursive calls, right? And define each recursive call so that it makes progress to base case, base, that is BAC, base case, right? Now here, in this case, here I discuss some recursive algorithms using the notepad part, right? Now here in the some recursive algorithms where we have to define it inside the recursion part, and recursion main thing is that the function calls itself, right? Now in this case, that is the some recursive algorithms, when we have to define it, then suppose at first the first case we have to go through some recursive algorithm here, but at first we see that how a recursive algorithm is written. Now that is how the particular recursive algorithm is generated or written. So suppose a problem has the following recursive definition. Here I write down this thing, that is the problem. First problem is fx equal to c for some gx. Here I write down in the notepad. Okay, so this is the first one. Okay, and this is equal to f of hx for other values of x. So this is the second one. Okay, here I write down in the notepad. Okay, now in this case, here the condition 1 is the base and condition 2, that is the last condition, implies recursive call. So for x equal to gx, here I write down this thing. So for x equal to g of x. Okay, so here I write down. So for x equal to g of x. Okay, return the value c to the calling function, and for the other values of x, calls the same function with the new argument here h of x. Here I also write down this thing in the notepad, that is h of x. Okay, h of x, right? Now here, so if we write down the algorithm of f of x, so suppose the function name that I write down fn of f of x, right? So this thing I write down in the notepad, that is this. Now how can we basically here generate the algorithm? This part we have to discuss. So at first, based on the two conditions, so at first we have to check it using the if condition this. Okay, according to the above two mentioned condition, that is 1 and 2, right? And if the condition is satisfied, then according to rule number 1, it will return C. So here I write down return C. Okay, according to rule 1. Else it will return fn of f of h of x according to rule 2. So in the else block, here I write down in the else block, it will return this, and After that, we have to close our function. So in this way, we have to design the algorithm part of f of x, right? So using the above said part, we can implement any recursive function for any recursive solution of a problem. Now let us consider some problems here. Suppose the first problem is factorial function. Now the recursive definition to calculate the factorial value of a number is as follows. So I write down this thing in the notepad. So at first I have to omit this part. Okay. Then I write down this. Okay. So this is the first part according to the base criteria, or this is equal to n star fact of n minus 1 for n is greater than 1. Okay. So this is the condition. Okay. Now when we generate the algorithm part of this factorial function, then at first suppose the function name here we use fn fact, and it will calculate the factorial value of n. So that part will be treated inside the argument part of this function name fn fact. Okay. Now the purpose of this algorithm is to calculate the factorial of a positive number, and here n is the given number. So this function returns -1 for negative value of n, otherwise return factorial of n. So at first we have to check whether the n value is lesser than 0 or not. That is for checking whether the n value is negative or not. So according to the condition here, at first this condition is checked, and if this condition is satisfied, so according to the rule it will return -1. So I have to write down this thing. So return -1. Otherwise, that is go to the next condition. That is at first we have to check the base criteria. So the base criteria is according to the rule if n equal to 1 or 0, right? So this is the base criteria. So then in the next case we have to check it. So this is the base criteria, and if this condition satisfied, so according to the rule 1 it will return 1. So it will return 1. Okay. So it will return 1. Otherwise, that is go to the else block. So according to the rule 2, it will return n star fact of n minus 1. So this is the one example of recursive call, because here also the function name fn fact calls itself. So in this way we have to implement the recursive function of factorial function part, right? Okay. Now let us calculate the value of factorial 4 using the recursive algorithm part of factorial function. So how can we calculate it? So at first we have to write down fn of fact of 4. That is, here we have to calculate the factorial value of 4. So at first we have to write down this thing. So this part according to this function block, it will return at first 4 star fn factory, because if n is greater than basically 1, then it will return n star fn fact n minus 1. Now here n is 4, so fn fact 4 minus 1, which is 3. So 4 star fn fact 3. Okay. Now this part, so here fn fact of 3, so here n value is 3, which is greater than basically 1. So fn fact 3, it will return 3 star fn fact 2. So this part here I omitted at first. One by one we have to consider this. So this. Okay. Now fn fact 2, this is equal to 2 star fn fact 1. Okay. So 2 star fn fact 1, this thing I write down in the notepad. Okay. Now look, here n value is 1, which satisfies the second if condition. That is, if n equal to 1 or n equal to 0, it will return 1, which is the base criteria of the factorial function. So we have to write down fn fact 1, this is equal to 1. Okay. Now as we get the 1 part, so we have to backtrack it. So Fn fact 2, this is equal to, therefore 2 star 1, which is 2. So here I write down this thing. Then again we go to Fn fact 3, which is 3 star 2, that is 6. So I write down here in this block, so that is 6. Now Fn fact 4, this is equal to 4 star 6, which is 24. So finally we have to get the factorial value of 4, which is 24. Okay. Now in the next case we have to consider another recursive function for calculating the GCD of two numbers. Okay. Now according to Euclid's algorithm, the recursive definition, the GCD value of two positive integers x and y is as follows. Here I write down this thing in the notepad. So this condition is this. So this is the first condition. Okay. And in the second part, this is equal to y if x is greater than equal to y and x mod y, this is equal to 0. So this is the second condition. Okay. And lastly, this is the GCD of x comma x mod y if x is greater than y. Okay. So this is the last condition. So after basing on these conditions, we have to develop the recursive function of GCD algorithm, right? So this algorithm calculates the GCD value of two numbers, and here the inputs are x and y, as I told, which are the two positive integers, and here we assume that x is greater than y, and the output of this function is to calculate the GCD value of x and y, right? So here at first I have to write down the name of this function, which is fn GCD of x comma y. Okay. Now here in this function definition block, we have to first consider the base criteria. Okay. And here we assume that x is greater than y. Okay. So this is the base criteria. Okay. So we have to use this condition for base criteria. Then it will return y according to rule 2. Okay. So it will return y. Can I write down this thing? Otherwise, we have to go to the else block. Okay. So here the function then calls itself. So we have to write down inside the else block, that is, here we write down else, then this. And finally, we have to close our algorithm. So in this way, we have to implement the recursive function of GCD algorithm, right? Now, let us basically describe how the execution of this algorithm to calculate the GCD value of 10 and 6. Now look, here 10 is x and 6 is y. Okay. So here we have to write down this thing in the notepad. So this. Okay. Now, so as x is 10 and y is 6, so according to this function block, so this part is this thing fn GCD 6 comma 10 mod 6, which goes to the next block. So I write down this thing here, this. Okay. Then after that, it will right now fn GCD 4 comma 6 mod 4, right? So I write down this thing, this. Okay. Now, as here 4 is greater than 2 and 4 mod 2, this is equal to 0. So fn GCD 4 more comma 2, it will return 2. So I write down this thing in the notepad. So finally this is fn GCD 4 comma 2. So this will return 2. Okay. So if we backtrack it, then we can write down this thing in this way. That is, last fn GCD 4 comma 6 mod 4 is 2. Then we go to the previous part, fn gcd 6 comma 10 mod 6 2, and then we go to the final part, that is fn gcd 10 comma 6, which is also 2. So that is, in other words, we here perform the backtrack, and finally the result is here is 2. Okay, so in this way we have to backtrack, and finally we have to get this 2 value of fn gcd 10 comma 6. Okay, so in this way we have to calculate the gcd of two positive numbers, where the first number x is greater than y. Here we have to assume. Okay, now the next part, here we have to design the recursive algorithm of exponential power. Now we can define a recursive function to compute the value of x to the power n as follows. Now first one, power of xn is equal to 1 if n equal to 0, because any number power value 0 is 1. Okay, so before I starting this, at first I have to omit this part. Now we have to write down this condition. Okay, now so this value is x if n equal to 1. Okay, so in the second condition we have to write down this. Okay, now go to the third condition. So this part is power of x comma n by 2 into power of x comma n by 2 if n is even and n is greater than 1. So I have to write down this part here. Okay, and finally I have to write down the last conditional part if n is odd and n is also greater than 1. So in this case, this thing is x into power of a x comma n minus 1 by 2 into power of x comma n minus 1 by 2. Okay, so this is the rule for calculating the exponential power of a particular number. Okay, so when we design the algorithm which computes x to the power n using recursive function, so at first I have to write down the function name, and here two arguments we have to use. One is the number for x and another one is the exponential value, which is here n. Okay, so this algorithm computes x to the power n, right? And x is here mantissa and n is exponent. Okay, so output is the value of x to the power n. So at first we have to check the base criteria part, that is if n equal to 0 or not. Okay, now if n equal to 0, then obviously according to the rule it will return 1. So in this case this will return 1. Okay, so I have to write down this thing inside a notepad. Okay, otherwise if n equal to 1, this is also another base criteria. So in this case here it will return x. Now look, here the basic difference between factorial of a number and the exponential power of this part is that here for n value 0 and n value 1, different value we get. But in the factorial case, for n value 0 and as well as also n value 1, it will return the same value, which is 1. So these two base conditions here merged into the if conditional block into the single part. So that's why in the factorial function we have to write down if n equal to 0 or n equal to 1, it will return 1. But this thing not happen in the exponential power problem, because for different value of n, that is for n is 0, it will return 1, but when n is 1, it will return x value. Okay, that is the number part. Okay, so that's why we have to separately consider the condition of n equal to 0 as well as also n equal to 1. So if n equal to 1, as I told, it will return x, because x is the number, right? Now after that we have to check another condition, that is if n is greater than 1 and also n mod 2 equal to 0, that is for even number part, that is if n is even and also n is greater than 1, then what will be the value it will return. So according to the rule, we have to at first use the if conditional block, and then after that if the condition is satisfied, that is two conditions are satisfied at a time simultaneously, then it will return the fn power x comma n by 2 into fn power x comma n by 2. So this is one recursive call. because here the function calls itself. Okay. Next we consider another recursive call. That is where we have to check the n value is odd as well as n is greater than 1 or no. So here also we have to use another if condition. Okay, and according to the rule, again here we use one recursive call and it will return, that is the x into fn power x comma n minus 1 by 2 into fn power x comma n minus 1 by 2 according to the rule. Okay, so it will return here, and finally we have to end our algorithm. So in this way we have to develop the exponential power part of the using the recursive algorithm. Okay, and lastly here I also consider another program that is called Fibonacci sequence. And as all of you know that the Fibonacci sequence here is as 0, 1, 1, 2 in this way. That is the third number is the addition of the previous two numbers. And here the first two numbers are fixed, which are 0 and 1. So the recursive definition to calculate the nth number in the above series can be stated as follows. That is fib of n equal to n for n equal to 0 or 1, right? So I write down this thing in the notepad part. So I write down this part in the notepad section, right? Okay, and for n is greater than 1, this will be the addition of the previous two Fibonacci part. So for n is greater than 1, this thing will be written as this. Okay, so these are the two conditions of the Fibonacci sequence series. Now using these two conditions, how can we generate the recursive algorithm of the Fibonacci sequence series? So when we have to develop the algorithm, this algorithm finds the nth number in the Fibonacci series using the recursion procedure. So here suppose the function name is fn fib, and here we use only one argument, that is the n, which is an integer, and the output of this function is the value of the nth number in the Fibonacci series. So I have to write down this thing. Okay, now here at first we have to check the base criteria, that is if n equal to 0 or n equal to 1. Then in this case, according to the rule, it will return n. So this, okay, if any one part matches, then it will return n. So this is the base criteria. Okay, so it will return n. Okay, otherwise we have to consider the else block. So in this case it will return fn fib of n minus 2 plus fn fib of n minus 1. So here we have to use the recursive call because the function call itself, and finally we have to close our algorithm. So in this way we have to develop the Fibonacci sequence series using recursion, right? Now here, so we have to discuss different types of recursion techniques here. Then as we consider the recursion versus iteration part, now there are some differences. Now in the iteration block, here basically it is the process of executing a statement or a set of statements repeatedly until some specific condition is satisfied. Whereas in the recursion part, recursion is the technique of defining everything in terms of itself. Now, iteration involves 4 clear-cut steps. That is, number 1 is initialization, then condition, then execution, and updation. Okay, but there must be an exclusive if statement inside the recursive function, specifying stopping condition which indicates the base criteria. Now, whereas in iteration part, any recursive problem can be solved iteratively. But whereas in the recursion part, not all problems have recursive solution. Now, lastly, iterative counterpart of a problem is more efficient in terms of memory utilization and execution speed. But recursion is generally a worse option to go for simple problems or problems not recursive in nature, right? So these are the some differences between recursion and iteration. Okay. Now here, after that, here we have to discuss the some disadvantages part of the recursion. And the disadvantages of the recursion are: number one, it consumes more storage space because the recursive calls along with automatic variables are stored on the stack. Okay, and you know, in the stack part here, last in first out operation occur, and this stack portion already I covered earlier. Okay, now in the second point of the disadvantage part of the recursion is that if proper precautions are not taken, recursion may result in non-terminating iterations, which is very dangerous. Okay, that is, again I repeat, if proper precautions are not taken, recursion may result in non-terminating iteration, right? And lastly, it also slows down execution speed, as function call require jumps and saving the current state of program onto stack before jump. Okay, so this is also major disadvantage point of the recursion, that is, it basically slows down the execution speed, as function call require jumps and saving the current state of program onto stack before jump, right? Now I go to the PPT portion where I have to discuss also some more points related with the recursion part. Okay, now here also, so right now we have to totally distinguish between recursion and iteration part, right? Now here, when we consider about the recursive thinking, so many common problems can be stated in terms of a base case, which I already described, and an inferred sequence of steps to develop all examples of the problem statement from the base case. Okay, now let us look one possible definition of the .csv list. Okay, so a list contain only one item, so this is the base case, and a list can contain one item, also a comma and a list, the inferred sequence of steps in this case. So this above part, definition part of the list, is recursive because the second portion of the definition depends on there already being a definition for a list. So I go to the earlier slide. So in this case, so list can contain one item, and the second case can contain one item as well as comma and a list also. Okay, so this part again calls itself the list. So this is also another example of the recursive operation. Okay, and the base case here gives us a mechanism for ending the circular action of the second portion of the definition, because every recursion, when needs the termination part, then it will call the base value. Okay, but without using the base value, recursive function never terminates. That is, it goes to the non-terminating criteria in this case. So as I already told in the disadvantage part of the recursion operation. So this is the very dangerous part. Okay, now also we keep applying the recursive second portion of the definition until we reach a situation that means the first portion of the definition. First portion means here the base case, and then we apply the base case definition, right? Now suppose let us take an example. So this is the basically list is a number, list is a number comma list. These two separated lists. So this is the number comma list, because 88, then comma 40, then comma 37. But if we consider only single number, that is 37, this is also a list. Okay, this list is a purely number part. Okay. Now we go to the next part, that is the infinite recursion. That is, as I already told, that if no base case is there, then recursive function cannot terminate it. Then it go to the infinite case. Okay, and then use of a recursive definition becomes infinitely long because there is no base case. And any program based on that recursive definition then will never terminate and produce a result, because if the particular problem never terminates, then we never get any feasible solution. Okay, so this thing is similar to having an inappropriate or no condition statement to end a for loop, while loop, or do while loop, right? So if when we implement the recursion concept in the math, so this way we have to design it. And one of the most obvious math definitions that can be stated in a recursive manner is the definition of the integer factorial. That is this thing. Okay, so I already described this part, so I just keep it. And here also, here we consider one Java program where we have to implement the recursive concept. Okay, now recursion versus iteration using the programmatic part, as I already discussed about the theoretical part. So here, if when we calculate the factorial of 5 using a loop part, that is the iteration part. So here I declare it in fact 5 factorial equal to 1. Then here we have to use the for loop, and after that we have to assign this, that is 5 factorial equal to 5 factorial star I, and every time this thing is multiplied, and finally we get the result value of 5 factorial. But what happens when we implement this thing using the recursion part? Then in this case we have to write down this condition, that is if here we have to use the conditional operator, that is if n equal to 1 this thing is true, it will return 1, else it will return instead factorial n minus 1. Okay, so in this way we can classify the programming example of iteration versus recursion part. Okay, and every recursion part must contain the base value, and without base value recursive function never be terminates, right? So I have to close my today's lecture